In the final years of World War II, a ruthless race began in the clouds, nations throwing their last hopes into machines so fast they tore the sky apart. But only one fighter earned a whispered title among terrified pilots, the King of Speed, and its crown was never guaranteed. By 1943, the war in the air had entered a new and unforgiving phase. The early improvisations of 1939 and 1940 were gone. Every nation still standing in the conflict understood that control of the skies no longer supported the war effort that determined it. Cities, factories, supply lines, and entire armies depended on what happened thousands of meters above the ground. Air superiority had shifted from an advantage to a requirement, and speed became the currency that dictated survival. Aircraft designers on all sides now pursued a single measurable truth: the faster fighter lived, and the slower one died. A higher climb rate meant reaching bombers before they released their payloads. A faster dive meant breaking away from a superior enemy. More speed and level flight meant dictating the terms of the engagement, pouncing when the moment was right, or disappearing into the horizon when the odds turned impossible. Across Europe and the Pacific, pilots described the same reality. Reaction time shrank, and decisions were made in seconds. In this environment, speed was no longer a performance metric, it was a weapon. The Allied and Axis powers responded with machines that pushed engineering to its edge. In the United States, the P-51 Mustang emerged as a long-range escort capable of matching Germany's best fighters while protecting bombers deep over enemy territory. Its combination of aerodynamic refinement and the Rolls-Royce Merlin engine made it one of the fastest piston-engine fighters of the war. Alongside it, the P-47 Thunderbolt, massive, rugged, and unexpectedly fast in a dive, proved that size was no barrier to extreme performance under pressure. Across the Channel, Britain continued evolving the iconic Spitfire. Late-war variants powered by the Griffin engine reached speeds unimaginable in 1940, turning the aircraft into a formidable, high-altitude interceptor for the Soviet Union. The lightweight Yak-3 brought exceptional agility and speed to the Eastern Front, where low-altitude dogfights dominated the fighting. Germany responded with innovation shaped by desperation. The FW-190D9 extended the capabilities of the FW-190 line, offering speed and climb performance that challenged Allied superiority. But it was the Messerschmitt Me 262 that changed expectations entirely. As the world's first operational jet fighter, it represented a technological leap, capable of speeds that left conventional piston fighters struggling to react. These aircraft, each shaped by different doctrines, landscapes, and pressures, defined the last years of aerial combat in World War II. Yet even as they pushed the boundaries of engineering, one question remained unresolved. In the final contest of speed, which fighter truly ruled the sky? The P-51 Mustang entered the war not as a miracle of aviation, but as a troubled experiment. When North American aviation first delivered the aircraft in 1941, it carried the Allison V1710 engine, a power plant that performed well at low altitudes, but struggled above 15,000 feet. In early operational testing with the Royal Air Force, pilots reported that the Mustang's performance dropped sharply in high-altitude combat, making it unsuitable for the interception roles Britain desperately needed. The airframe showed promise. Its laminar flow wing, long range, and clean aerodynamics were undeniable, but without the right engine, it was a fast aircraft trapped in the wrong part of the sky. The breakthrough came in 1942, when British engineers proposed fitting the Rolls-Royce Merlin engine into the Mustang's fuselage. This was the same engine family that powered the Spitfire and Hurricane, already proven over Europe. The decision created the P-51B and P-51C, transforming the aircraft almost overnight. With the two-stage, two-speed supercharged Merlin, the Mustang gained exceptional high-altitude performance, improved climb rate, and a top speed that now exceeded 430 miles per hour. What had been a limited support aircraft became one of the Allies' most formidable fighters. When the 8th Air Force began long-range strategic bombing over Germany, the Mustang finally revealed its full value. Its range allowed it to escort B-17 and B-2 for bombers deep into enemy territory. Berlin, Leipzig, Munich, distances no previous Allied fighter could confidently reach. Pilots described missions lasting 6 to 8 hours, guiding bomber formations through some of the most heavily defended airspace in Europe. Many veterans recalled the emotional weight of watching bombers limp home behind them, engines damaged, crews wounded, but still alive because the Mustang had held the German interceptors at bay. In combat, Mustang pilots pushed the aircraft beyond its official limits. In steep dives against Bf-109s and Fu-190s, the Mustang approached near transonic speeds, with some pilots reporting compressibility effects, heavy controls, buffeting, and reduced elevator authority. Its laminar flow wing reduced drag but became less stable as airflow broke down near the speed of sound. While the Mustang could dive faster than most German fighters of the time, these aerodynamic limits served as a reminder that even the best piston-engine aircraft were approaching the boundaries of propeller-driven flight. Despite these challenges, the P-51 maintained an extraordinary combat record. By the end of the war, Mustangs claimed thousands of aerial victories and secured the skies over Germany in 1944 and 1945. What began as a flawed design had become one of the fastest and most effective fighters of the conflict, an aircraft forged from necessity, refined by innovation, and carried to its peak by the pilots who trusted it with their lives. By the final years of the war, the Supermarine Spitfire, already a symbol of Britain's defiance, underwent its most dramatic transformation. Early variants had saved the nation during the Battle of Britain, but the demands of 1944 and 1945 required a fighter far more powerful than anything envisioned in 1940. The answer came with the introduction of the Rolls-Royce Griffon engine, a larger, more powerful successor to the Merlin. Its adoption created a new generation of Spitfires, the Mk-14, followed by the Mk-18 and the fully redesigned Mk-21. The Spitfire Mk-14 entered service in early 1944, powered by the 2,000-horsepower Griffon 65 engine. This upgrade changed the aircraft's character entirely. The Griffon's torque required a redesigned vertical stabilizer, and the Spitfire's once familiar silhouette now carried a more aggressive profile. In return, pilots gained a climb rate that rivaled or exceeded anything in the Allied inventory. The Mk-14 could reach 20,000 feet in under 7 minutes and achieve speeds above 440 miles per hour in level flight performance, critical for intercepting V-1 flying bombs and engaging the latest German fighters. Later variants continued this evolution. The Mk-21 introduced a strengthened wing, redesigned control surfaces, and structural reinforcement to handle even greater power. Although it arrived late in the war, it represented the Spitfire pushed to the limits of piston engine technology. Test flights recorded speeds approaching 460 miles per hour, placing these late-war Spitfires among the fastest propeller-driven interceptors ever produced. Yet the Spitfire's reputation extended beyond its performance. British pilots formed a bond with the aircraft that few machines ever inspire. Its light control feel, exceptional maneuverability, and responsiveness created a sense of trust in combat. Many airmen described the Spitfire not simply as an aircraft, but as an extension of their instincts of fighter that reacted almost the moment thoughts formed. This emotional connection endured even as the aircraft evolved into a heavier, more powerful late-war machine. By 1945, the Spitfire had transformed from a nimble defender of the British homeland into a high-performance interceptor capable of meeting the most advanced German aircraft head-on. The legend remained unchanged, but its final evolution showed how far a timeless design could be pushed when history demanded more from a symbol that had already given so much. The Messerschmitt Me 262 entered the war as a machine unlike anything the world had ever seen. When it became operational in 1944, it was the first jet fighter to see combat, a technological leap so large that Allied intelligence initially refused to believe the reports. Its twin Junkers Jumo 004 engines pushed it to speeds exceeding 540 miles per hour, nearly 200 miles per hour faster than most Allied piston engine fighters. For pilots accustomed to dogfights fought at the limits of propeller-driven performance, seeing a Me-26 streak past was a moment of disbelief. Many airmen later said it felt as if a weapon from another era had suddenly arrived on the battlefield. In combat, the aircraft proved devastating when used to intercept Allied bombers. Its speed allowed it to penetrate defensive formations before escort fighters could react. A well-flown Me-262 could make a firing pass on a bomber group, unleash a burst from its 30mm Mk-108 cannons, and disappear before the formation's guns found their mark. Allied pilots described the shock of watching the jet accelerate away, its engines emitting a distinct whine, its silhouette shrinking faster than anything they had trained to counter. Yet the Me-262 carried within it the limitations of a nation under extreme pressure. The Jumo-004 engines, built with wartime shortages in mind, relied on inferior metals that could not fully withstand the stresses of jet propulsion. Service life averaged just 25 hours, and sudden mechanical failures were common. Pilots learned to avoid rapid throttle changes, which could cause compressor stalls or catastrophic engine fires. Even when functioning well, the engines required long, vulnerable takeoff runs, making Me-262 bases prime targets for Allied strafing attacks. Strategic decisions compounded these technical problems. Adolf Hitler insisted that the aircraft be developed as a fighter bomber rather than a pure interceptor, delaying its deployment and diverting production. By the time dedicated fighter units such as Jagdgeschwader 7 received the Me-262 in significant numbers, Germany faced crippling fuel shortages that limited training and sortie rates. Many pilots flew their first jet mission with only a handful of hours in the cockpit. Despite these obstacles, the men who did master the Me-262 spoke of it with awe. Luftwaffe aces like Adolf Galland and Walter Nauotny described the sensation of flying it as stepping into the future. Its acceleration, smoothness, and raw speed unlike anything they had experienced. Allied pilots who encountered the jet carried similar impressions. Reports from 1944 and 1945 repeatedly mentioned that no piston engine fighter could match the Me-262 in level flight. In the end, the Me-262 did not change the outcome of the war. It arrived too late, in too few numbers, and with too many mechanical and logistical limitations. But for a brief moment, it showed what aerial combat would become in the decades ahead. A glimpse of the jet age, delivered in the final months of a world at war. By late 1944, Germany was attempting to hold the skies with a shrinking industrial base and a rapidly advancing enemy. Yet even in these final months, German engineers produced piston engine fighters that pushed performance to the edge of what propeller aircraft could achieve. The Focke-Wulf FW-190D9 and its successor, the Tu-152, represented the pinnacle of this effort. Machines designed to counter high-altitude threats and nearly rival early jets in raw speed. The FW-190D9, introduced in the autumn of 1944, was a major redesign of the earlier FW-190A, nicknamed the Dora. It used the liquid-cooled Junkers Jumo-213 engine, giving it better high-altitude performance and top speeds exceeding 425 miles per hour. Pilots quickly recognized that the D9 could climb faster, dive more cleanly, and maintain competitive performance against late-war Allied fighters such as the P-51 Mustang and the Spitfire Mk-14. It arrived too late to change the broader strategic picture, but in individual encounters it demonstrated that German piston engine fighters were still capable of meeting Allied aircraft on nearly equal terms. The program culminated in the Tu-152, designed by Kurt Tank and intended to intercept high-altitude bombers and reconnaissance aircraft. The Tu-15H variant, fitted with the Jumo-213E engine and a pressurized cockpit, was optimized for extreme altitudes. Test flights recorded speeds around 470 miles per hour and operational ceilings above 40,000 feet. Performance levels that placed it alongside the fastest piston engine fighters ever built. In January 1945, Tu-152s entered combat with Jagdgeschwader 301. Real encounters were few, but those that occurred left strong impressions. One recorded engagement involved a Tu-15H1, flown by Oberleutnant Joseph Kiel, who used its altitude advantage to dive onto Soviet Yak fighters, demonstrating the aircraft's remarkable high-altitude control and speed. These fighters became the final expression of German piston engine design machines, created under conditions of scarcity, but capable of performance that rivaled early jets in certain regimes. Yet their impact remained limited by production delays, fuel shortages, and the collapsing state of the Luftwaffe. Fewer than 700 FW-190D9 South were built, and only a few dozen Tu-152s reached operational units. Their rarity gave them a near-mythical status among pilots and historians, symbols of what German engineering could achieve even in the final months of the war, and reminders of how close piston engine technology came to its ultimate limits before the jet age swept it aside. The Republic P-47 Thunderbolt entered World War II as one of the largest and heaviest single-engine fighters ever produced. At first glance, it appeared more like a small bomber than a frontline interceptor. Yet beneath its massive frame and rugged construction, the P-47 carried a unique combination of power and resilience that made it one of the most formidable aircraft of the war. Powered by the Pratt & Whitney R2800 Wasp, the same engine that drove several of America's best fighters, the Thunderbolt delivered more than 2,000 horsepower and exceptional high-altitude performance. What set the P-47 apart was not just its speed in level flight, often exceeding 430 miles per hour at altitude, but its extraordinary behavior in dives. Its heavy weight and clean aerodynamic design allowed it to reach near transonic velocities when diving from great heights. Pilots frequently described the sensation of the aircraft running away from them as the controls stiffened and compressibility effects began. In several documented cases, Thunderbolts unintentionally exceeded redline speed during combat or training dives, entering regimes where airflow across the control surfaces partially stalled. Many pilots later credited the aircraft's structural strength for their survival. The P-47's thick wings, reinforced spars, and exceptionally strong fuselage allowed it to endure speeds that would have destroyed lighter fighters. Reports from the 8th and 9th Air Forces include instances of Thunderbolts pulling out of uncontrollable dives with severe control loads, only to return safely despite bent airframes or deformed panels. One common sentiment among pilots was that if any aircraft could survive a mistake at high speed, it was the P-47. In combat over Europe, the Thunderbolt combined this survivability with heavy armament and long-range capability. It escorted bombers, attacked ground targets, and absorbed damage that would have crippled most fighters. German pilots respected and often feared the P-47's durability. Though large and seemingly unwieldy, it earned a reputation as one of the most reliable and fastest diving fighters of the war, a machine that proved size alone could not define an aircraft's role or performance in the crucible of aerial combat. On the Eastern Front, where air combat occurred at lower altitudes and in brutal conditions, the Yakovlev Yak-3 emerged as one of the Soviet Union's most effective fighters. Entering service in 1944, it was designed with a philosophy centered on simplicity, lightweight construction, and exceptional maneuverability. Its compact frame, wooden components, and minimal equipment made it one of the lightest fighters of the war, resulting in remarkable acceleration and agility. Below 15,000 feet, the altitude band where most Eastern Front engagements unfolded. Despite its modest appearance, the Yak-3 delivered performance that surprised both Soviet pilots and their German opponents. With a top speed exceeding 400 miles per hour at low altitude and an exceptional rate of climb, it excelled in the tight, fast dogfights typical of the region. On several occasions, German commanders warned their units to avoid combat with Yak-3 fighters below 5,000 meters unless holding a clear advantage. Encounters with Bf-109 gigaseconds and FW-190 has revealed that the Yak-3 could outturn, out-accelerate, and often outclimb its adversaries in close combat. The aircraft's reputation was reinforced by the experiences of pilots from the Normandie-Niemen regiment of French fighter group operating under Soviet command. Their combat reports praised the Yak-3's responsiveness and its ability to hold energy through rapid maneuvers. Many pilots emphasized how the aircraft felt almost weightless in the air, allowing them to engage and disengage with precision. These qualities contributed to the regiment's impressive combat record during the final year of the war. Soviet pilots also formed a strong emotional connection to the Yak-3 after years of flying heavier or less reliable designs. The aircraft's reliability and ease of maintenance were welcomed advantages. Ground crews appreciated its straightforward construction, which allowed damaged airframes to be repaired quickly on rough forward airfields. For many airmen, the Yak-3 represented a turning point, a fighter that finally matched or exceeded the performance of German aircraft in the conditions that defined the Eastern Front. Although produced in limited numbers compared to other Soviet designs, the Yak-3's combat achievements and pilot testimonies established it as one of the most respected and effective low-altitude fighters of World War II, an unexpected contender that earned its reputation through precision, simplicity, and frontline success. By 1944, the pursuit of speed had become a global competition, but the numbers recorded in manuals or propaganda sheets rarely matched the realities of combat. True speed was not a single measurement. It was a combination of factors shaped by physics, engineering, and the chaotic conditions of war. The first metric was level speed, the aircraft's maximum velocity in controlled, horizontal flight. This was the measure most often quoted by designers and governments, but it depended heavily on altitude, air temperature, and engine condition. Even small changes in fuel quality or airframe cleanliness could alter the results. Dive speed told a different story. It reflected both aerodynamic design and structural strength. Heavy fighters like the P-47 could reach near transonic velocities in steep dives, surpassing the official limits noted in technical manuals. Lighter aircraft with thinner wings often encountered compressibility effects earlier, limiting how far pilots were willing or able to push them. Combat speed, the velocity an aircraft maintained during turns, climbs, and sudden maneuvers, revealed how performance translated into real engagements. Many fighters advertised impressive top speeds but lost energy rapidly when maneuvering. Others, like the Yak-3, excelled at maintaining high speeds in low-altitude dogfights. Sustained power added another layer. Engines behaved differently under extended strain. Some fighters excelled in short bursts, while others maintained high output over long missions, especially in hot, dusty, or fuel-restricted environments. Finally, reliability under stress often reshaped official claims. Wartime testing sometimes yielded optimistic brochure speeds, influenced by propaganda or ideal test conditions rarely replicate in combat. Operational realities: engine wear, field repairs, limited fuel quality, and clogged air filters meant that no single number could determine supremacy. These contradictions ensured that the question of the fastest fighter remained complex. The contest for speed was not just a race among nations, but a struggle between the limits of physics and the ambitions of wartime engineering. When the final measurements were compared, the race for the fastest fighter did not yield a simple victor. Each contender dominated in different environments, altitudes, and flight regimes, revealing how broad the concept of speed truly was. In level flight, no piston engine aircraft could match the Messerschmitt Me 262. Its twin-jet engines pushed it past 540 miles per hour, placing it in a category beyond the reach of propeller-driven designs. In head-on or chase scenarios, the jet could dictate distance and timing with ease, earning its place as the fastest operational fighter of the war. But when the contest shifted to maximum dive speed, the crown moved elsewhere. The American P-47 Thunderbolt, with its immense weight and reinforced structure, routinely reached near transonic velocities in steep dives. Pilots who unintentionally exceeded redline often returned with bent control surfaces or stressed airframes, but alive. No other combat aircraft of the war repeatedly survived such extreme aerodynamic punishment. At high altitude, the German Tu-152 stood alone, reaching speeds around 470 miles per hour above 40,000 feet. It operated in a realm where few fighters could even breathe. Its combination of supercharged power, long wings, and pressurized cockpit made it the fastest and most capable piston engine interceptor at extreme height and harsh environments. Speed was only one component of their effectiveness. Endurance and adaptability completed the picture. So who wears the crown? The answer depends on the category. The Me 262 ruled pure level speed. The P-47 dominated the fastest dives. The Tu-152 owned the upper atmosphere. The Mustang and Spitfire mastered the vast middle ground of sustained wartime operations. In the end, speed shaped the machines, but pilots shaped history. The aircraft pushed engineering to its limit, but it was the airmen who navigated those limits, survived them, and wrote the final chapter of aviation's most intense era.